This video is for a gentleman, my friend in the Netherlands, who I upset for a good reason, and I apologize. His name spelled in English is G-U-U-S. To us in America that would spell like Gus. But I looked up the name on the internet, and it's one thing Americans can't do. Americans cannot speak his name, which I hate to say is I can't do it. Anyway, his name in the Netherlands is, and this is not going to sound like great, it's Guus. That's as close as I come to it. Anyway, his question was, shouldn't the carburetors from the stock engine on the 50, which is here, which is 14 millimeter, shouldn't they be comparable to the whole intake track going into the engine, into the cylinder, and out? And I would say yes, but it's a long story. So anyway, this video is for him. His screen name is Zamarden, I believe. That's as much as I know. This is your intake right here. You see how small that is? This can't be changed. We can change the carburetor size right here. From stock, we can change the intake size from the reeds to this, from this to this. And we can take the stock exhaust and we can put on bigger exhaust. There's three of them right there, stainless steel. Fongier big boy and Fongier stock lung pipe. Now, it's a simple question, but it's a very complicated answer. And I believe the question was, shouldn't the bore and stroke be equal to the carburetor intake size and the exhaust? And yes, it should. Now I have to ask you, this is a Honda Dio engine between 1994 and 2001. Have you ever seen them break compared to the Chinese ones? No, you haven't. Why? Because Honda spent millions of dollars in development. They also spent millions of dollars to figure out the exact carburetor size, the exact intake size, the exact cylinder size, which this is your stock piston right here. You can see how tiny it is. See? Okay, this is one of the bigger ones. This is probably 98 cc. You can see how much bigger it is. Or we can take that and put it on top. Now, Honda engineers did not just slap this together and say, look, let's put on something shiny here and something shiny there and this size. This is all worked out by a computer, which they didn't have at the time, and their ratios, which are astronomically hard to figure out. Even a rocket scientist would have a hard time figuring it out. And there are a lot of Japanese trade secrets that we don't know about. But suppose this engine could put out 12,000 RPM at its top speed. A standard from beginning all the way up to 12,000 RPM. Okay, that's power band. Now it's constant. Now what the carburetor and the intake and the piston and the cylinder and the exhaust do is change that power range to a usable power range for the rider, along with the gearing on this side, the rear gearing, and the front variator. Now when we go to change the carburetor or one part of this motor, we've screwed up all their all the Japanese calculations. When you go to change the intake, you screwed it up some more. When you go to change piston sides, you screwed it up a lot. And when you go to put on a bigger exhaust, you've really screwed it up. So that's why it is good to have, it is especially good to have, on your crankshaft, you should have, if the bore and stroke is 50 millimeters, you should have a 50 millimeter crank. You should match the bore and stroke to the pistons. You should. Now the theory of horsepower, this will help also. Remember, these little engines, and all engines, like my 800 horsepower Camaro that I built, they're air pumps. And if you look closely, this has a 18-inch supercharger on the top of it, 671 blower, 3-inch Krager drive belt, two 600 Hollies, which I built when I was 17. But that's not what I meant. This supercharger, what it does is takes air over atmospheric condition and pumps it into the motor, which would not be in there to be normally aspirated. And what it does, a supercharger does, and it can be a turbocharger, which is a supercharger, or it can be any type of supercharger, it rams more air and fuel through the engine. Now the more air and fuel that goes through an engine, the more horsepower is created. So with the larger carburetor and the larger piston and the larger exhaust, we get to have more fuel going and air going through the system, making more horsepower. With this 427 cubic inch, I don't know how many millimeters, I don't know, 6,000 millimeters, this could cram twice as much air into the cylinders as normal. And what that would do is create twice as much compression, twice as much bang, twice as much air running through the air compressor engine, and create more horsepower. That's why there is no substitute for cubic inches, or bigger is better. As all my ex-girlfriend laughed at me and told me that. So the question is, yes, you should keep everything normal. But we can't with the block. The block here is the only thing we can't change. The intake is a problem because this is your normal Honda 50 carburetor. You have a carburetor, you have your intake. Look at the size. Here, your cylinder, and your exhaust. Now the motors that I build have this little problem with them. We have a giant carb. We have the same size intake, which is right there. You can't change these intakes very much. We also have a large cylinder and a large exhaust. Now, what our books tell us about the exhaust, and you can see this is the pipe. You can see the piston right there, but the pipe is not just put together and guessed at. Everything is done by equations in RPM. So you may get a power pipe that says, yes, we'll give you more power. Well, yes, it will. It may give you more power in a different power range, but it will not make more power to the engine. It will just change the dynamics. You may get more power high end or low end. So with you have a lot of air going into a little area, into a big area, into a big area. This is a weakness right here, because you can have a, suppose we have a, this is my garage door right here. Suppose we have this garage door, okay? We open it up and we have air flowing through it, to the bike, to me. But the air has got to pass through this garage and it has to go out this door right here. And I'll open that door. Okay, do you know what the volume is of the air that passes through these doors? You say, well, I've got this huge intake right here. This is an intake. All those pink things are intakes. But they have to go into the carburetor from that door. Do you know what the volume of air is? The volume of air is that door right there. That's the weak spot. The door should not be there. It should be as big as the carburetor, which would be the whole wall. So that, I tried to explain that question. Anyway, I hope that I did, and I hope you get back to me. Guus, I can't pronounce it right. So anyway, this is for him.